We're at the fifth example for the Cupertino Robotics Project CNC. And in this example, we're going to continue with the fabrication of a plate. But we're going to make the plate a little bit more complicated by putting a couple of holes in the plate and a long slot. So the plate may be able to run in a pin as it moves back and forth in a pin. The approximate time for this video is also about 20 minutes. As always, we really want to show the appreciation for those organizations and people who made this possible. We start with the Gene Haas Foundation. Also, we want to thank the Fremont Union High School Foundation, Tormac Corporation, and Dassault Systems with their SolidWorks CAD, computer-aided design, and computer-aided manufacturing, or CAM. And then also we want to thank a couple of mentors who've worked with us for years, Doug Lowe and Dave Isant. And so in this case, we are in the plate with features, which is our fifth in this series. It's really important, and we stress it again and again, and I'm sorry for the repetition, but it's very important, is you cannot do this without the close supervision of a trained adult mentor. So make sure that you do not approach the mill, attempt to turn the mill on, attempt to load CNC machining instructions without a mentor being there and giving you specific permission to perform certain functions on this. So let's see what we're going to try to do. So we did a simple plate, and so this is not a simple plate anymore. It's a plate with features. So we had a simple plate that we started with before. We're going to use that same design, and then we're going to cut a couple of half-inch holes here. So maybe we could press some bearings in these half-inch holes, and then we're going to put a 3/8" slot on here. So maybe we could have something like a little pin here and run it back and forth in that slot. We're just making stuff up at this point. Okay, so we're going to use SolidWorks to do the design, and then we're going to use SolidWorks CAM to create the CNC code using the boss feature as well as the hole feature and the slot feature. And then we're going to put this all together and run it and actually do the fun part and make the fun part of this and to watch the physical part actually being fabricated. So this is going to be about 20 minutes. So let's get on and begin with the CAD, starting with the simple feature that we had done previously. In this example, we continue looking at the use of boss to make a plate, and then also adding features to that plate. So we're going to pick up that boss file, which is right up here, the boss design, and then we're going to add some things to it. So we are going to, let's go back into Sketch. And what does it mean we're going to add some things to it? We're going to add some things into this little plate. So I'm going to run here. I'm going to flip this around because I don't want it this way. Yeah, so I want the coordinate system to be up in that corner. Let's clear it up a little bit, and I'm going to get out of here. I'm going to pop over to my drawings. So I'm going to do a couple of things. I want something in that plate. I want to put a couple holes, and I want to put a slot in that plate as we had before, and then we'll see how to do that. Previously, we've shown how to extract this plate from the stock material. Now we're going to actually machine some things into this plate. So I'm going to pick up a sketch, and I'm going to put it right up here on this planar surface, and then I'm going to put a couple of circles. So I got a circle here. Let's go that, and I'm going to make it a half-inch circle. And maybe that half-inch circle would hold a bearing or some other thing we'd put in it. So here's another half-inch circle. And so remember the radius is 2.5 in this, and so we have it here. So then also maybe I want to put a slot here in this area so that it can slide maybe on a pin. So I would like to do a 3/8 pin, which is 3.75. I want to give it a little bit more room than that. So I'm going to make this slot a little bit bigger. I'll make it 0.38. So I'm going to punch up here, and I'm going to get here, and I want to take a look at this guy, and I'm going to make a slot that looks like this. I want it to be along here, and it seems to want to teeter-totter. Let me escape there. Let's do this again. Let me pick it up, and I'm going to pick it up here, center it, run it over here, make it big. There you go. Sometimes you have to start over. And so let's see what the slot is. I want to make that slot, let's say 4 inches. And then I want to make the slot, remember we said we're going to put a 3/8 inch pin through this slot to have it slide in that slot. So let's make this 0.380. And there's always a question on how much bigger do you make a slot or a hole to allow motion in it. And that's something you just have to pick up from the application and the materials. So here's your slot. Okay, so we have these features on here. Let's do a feature, and let's do an extruded cut. And I'm going to cut all the way through. Now, this is the thing we're going to make, okay? And so it's as that's why we call it. It's a plate, which is that kind of big slot or big oval, and then it is a couple of holes in it and and the slot in here. So we have it here. So I think that's enough. Let's go through and save it. It says save reminder. We've already done it. Okay, so let's pick up. We go to CamWorks, and then we can make sure that we come over here and pick up the tree. And let's see what the tree shows us. So the first thing we want to do is to define the. Oh, cool! This has already been defined because we've used an existing design. So we already have the post processor. Well, we already have the crib, the tool crib, plus the fact we already have it so that it says use only the tool cribs. So that's good. And let's see if it has a machine. Yep, we have that. We have a mill running in inches. So we got there. Okay, so that looks good. So we have the define the machine. Let's look at the stock manager on this thing. And so here's our stock manager. And we're going to, let's not make it out of aluminum. We're going to make it out of polycarbonate. So we click here on polycarbonate. And then we're going to, I think that's all we have to do on this. So we're good. And then we're going to get our coordinate system. Hey, isn't that cool? The coordinate system is where we want it. Let's just make sure, let's zoom in here and make sure the coordinate system is on the top of this. The origin of the coordinate system is on the top plane. Looks good. And so I think we have that. So we're all set. And then let's go, we have the coordinate system, stock manager, and let's do a setup. And we'll do a mill setup. And notice it's trying to get this front plane, which is this thing. Nah, we're not going to do that. We're going to do this top plane over here. So that's where it is. So I think we've done all the kind of initial setup for this. Let's pick this back up. Good. And now we're going to, we got to first now set up our boss. So how do we set up the boss? We want to cut this thing out, okay, on this. And so we're going to go to the mill setup. We right click, and then we come down here to 2.5 axis features, which is what this is what the mill is. 2.5 axis. And then what sketch do we use? Well, we have 3 sketches here. This sketch is, this is the 4th sketch, what we just added. So I suspect it's this sketch, and this is the sketch. So this is the thing we want to cut out as the plate. So that looks good. We have to tell it the end condition, and we're gonna do this. We're gonna make it blind, and notice it normally defaults for some reason to 0.394 inches. Okay, we want it to cut through the material. The material is 1/4 inch, so I'm going to put 0.25. Now, there's a problem with putting a 1/4 of an inch in decimal here. And the reason for it is we want to make sure we're guaranteed to cut through this material. Okay, so if we're just a little bit too shallow, we won't cut the complete plate. So I always like to add a little bit more, depending on the application, depending on what you're doing. That more, it could be anywhere from just a few thousandths to 1/10 of an inch. Okay, if it's 1/10 of an inch, it's kind of gross. Okay, and so what I want to do is I want to pick up another 2/100ths on this. So we're going to place this at 0.27. So we got this guy going. Looks good. Okay, and so there it is. There's the outbound pocket rough. Okay, so what I want to do is, that's not the only features here, right? That's actually not a feature. That's our boss. And so I better go back in because I think I made a mistake here. Let's go back in. Click on this. Okay, and notice I said pocket here. Did I want pocket? Nope. I wanted a boss. And so what I'm going to have to do, I can't change it here, okay, in the type. So I'm going to close this, and then I'm going to come back in here, kill this. Great, okay. And it always puts in recycle bin. I like to get rid of them immediately. Let's see what we can do now on this feature. Okay, good. So now I go to boss. See what I need to do? I have to tell it to boss, because if I tell it to pocket, what it does, it takes out all the material out. If I tell it to boss, all it does is acts like a router and just cuts around it, as we did in the previous simple plate. So I'll tell it boss. Okay, it's still sketch 3 I want to boss out, so that's good. And the end condition we talked about before is 0.27. Okay, so it wasn't bad. It's not the end of the world. Okay, so we did get that, and we got it finished. And see what I picked up on? It says it's a oblong round boss 1, and that's the name of it. This will be the finish. Let's generate the. Let's extract the features. Some more features. Okay, and now let's see what these features are. So this is the first one. That's the one we just did. That's the one we're going to use the boss. We'll cut that out. Here's another feature, and that feature is the oblong pocket here, around here. So you can see it's in that kind of a dark blue. And then here's one last feature, and these are the two. Those are the two holes. Okay, so looking good. So there's one issue I have. What it's going to do is going to cut the plate out first. Then it's going to cut the oblong slot in the plate, and then it's going to cut the holes in the plate. I really don't want to do it that way. I want to do all of the machining on this area first, and then cut the plate out, because I want everything to be clamped down. Because if you think about this, I am not going to clamp down this region here. I'm going to put a clamp over here, clamp over here, clamp over here, and a clamp over here. If I cut this out, the only thing I'll have holding this plate to get on the mill, and square on the mill, would be the tape that I have, and that's not enough for me. So what I'm going to do is I'm going to take this oblong boss, and I'm going to bring it down. So now what it says is I'm going to first cut the slot, then I'm going to cut the two circles, the half-inch circles, and then I'm going to cut the plate out. So the final step will be cutting the plate out. Okay, so that's pretty cool. Okay, so we generated all of the features. There's 3 features. I'm going to generate the operation plan. And then let's see what our operation plan says. Okay, it says that we're going to do this for a rough mill of the slot. Then we're going to do a contour mill to make it pretty, to clean it up. We're going to do a rough mill on the holes, the half-inch holes, and then we do a contour mill to do it, make it pretty. And then for down here, then we're going to do a contour mill here. Okay, and that's to cut out this. It's cut on the outside of that blue line, so we cut this thing out. Okay, but let's look at the tools it's asking us to use. It's asking us to use a 1/4-inch tool to cut the slots, and that's pretty good. Okay, it's asking us to use a 3/8 tool to do the rough and the finish contour. Nice. Okay, and it's asking us to use a 1/2-inch tool to cut the boss, or to cut the plate out. And that 1/2-inch tool is way too big. So let's go through and play some games with it. I'm going to double click on this. It takes a little while for it to come up. Here it comes. Okay, and I'm going to do, I notice that this is a flat end tool, and it has a 1/2 inch diameter. That's way too big. I want to use the 1/8 inch diameter tool. So I'm going to go down here to the tool crib, and I'm going to use the 1/8 inch. So right here is the 1/8 inch. How do I know it's 1/8 inch? Because if I were to get it wider, oh, here, I can see it here. See where it says 1/8 inch out here? So I'm going to go use that tool, and I'm going to select that tool. Okay, and I'm going to use the different tool holder, because remember, each one of our tools is loaded into its own tool holder. So yeah, let's use the new tool holder. Okay, so I think we have that one. And so we're looking pretty good. So I think we're done there. So, you know, I look at these and I say, yeah, these are reasonable tools to use here. So I think I'm good. Okay, so now I'm going to generate a tool path. And then I generate a tool path, and that's generating how the mill moves around. And I noticed down here I got a problem right here, because it gave me a little error message here on my tool path. So why is it giving me an error message? Well, let's see what's happening in this tool path. This is the finishing, or the contour, of these 2 circles, and we're using a 3/8 inch flat end mill. What the software is telling us is that mill is just too big, okay, to get a nice smooth finish. So we're going to have to make a change down here, okay? And we didn't know that beforehand, but that's fine, okay? So I'm going to go through and double click here. And I'm going to go into my tool crib, and I'm going to scoot over here. Okay, right now we're using a 3/8 inch. I'm going to convert that. I'm going to replace it with a 1/4 inch, which is right up here. And so I'm going to select that. Okay, and I want to select the holder, and then I think we're done. So notice what happened is that we have this 1/4 inch down here. Okay, but we still have an error message here. So how do we get rid of the error message? I'm going to regenerate the tool path. So I come up here, because that's where it generated the error message. I'm going to regenerate the tool path, and lo and behold, look what happened. Our error message went away, because we guessed lucky. Okay, actually, I did it before, and I had a problem with it, so I realized it was the 1/4 inch. It was the 3/8 mill end rather than the 1/4 inch. 3/8 works fine for rough milling. It doesn't work fine for when we go down here and do the smoothing. Okay, so we got this. You know something? I think we got everything we need. It sounds like it. Let's step through and just see if this thing makes sense to us. I like turning it up a little bit here. Okay, if I use the speed at this rate, I'll never see it. So, okay, so let's review what's going to happen here. Now, I turned it way down. I may have turned it up. The first step we have is to drill the slot and these 2 holes in our material before we ever cut the plate out. So we expect to see the slot, and when we do the slot, it's 2 steps. It's a rough mill and it's a contour mill. The same thing happens here when we do these 1/2 inch. We do 2 steps, a rough mill and a contour mill. And remember, the rough mill and the contour mill are different sizes now because we had to make that change from a 3/8 inch down to a 1/4 inch. And then the final thing we do is we run around here and like crazy, and we cut this thing out. Okay, so let's see if I'm right on this thing. So here it is. It's cutting. There's the big one. Here's the 1/4 inch. And then we're going to zip around. 1, 2, 3, 4, 5. There, you got it. So what we're doing on cutting, we're using 5 passes to cut this thing out. And 5 passes to cut it out, it basically says we're doing 50 thousandths per pass on this. And remember, we're cutting it a little bit deeper. So this looks good. You know, so I think I'm happy with that. What I see here. It doesn't mean it works. We'll have to get it on the mill to see it works, but I think we have something that makes sense. Okay, so I'm gonna say slip through that. Okay, now I'm going to pop up here, and I'm going to do a post processor, and I'm going to put this into this tape. This is the G code. I'm putting the G code into here, into that file, and then I have to run it to put it in the file. So don't just say I'm done. Push play, and there it is. And then let's go through. We're done with that, and this brings up the features. Let's see if it makes sense. This is the date I did it. Okay. It's going to take me 11 hours, 11 and a half minutes, hopefully not 11 hours. Okay, it's polycarb. Okay, it uses these 3 tools. It's 1/4 inch tool, a 3/8 and a half. Remember, or an 1/8, it wanted to use the 1/2 inch tool, but we decided that was way too big. Okay, and then what we're going to do is we're going to have these little statements, like here's N10. And N10, what it's going to do, this is going to cut the slot. Okay, so this is the rough mill of the slot, and it's basically from here to here. So that's the rough mill of the slot. Okay, here's the finish mill of the slot. Okay, and that's using the same bit. Okay, mill end. Okay, and that's to smooth it out. Okay, now here's the rough mill of a hole, the 2 holes. Okay, and here's the contour mill of the 2 holes, and it keeps on going down. Okay, and then what we do is we go down here, and this is where, so we have the, at this point in line 123, we have the slot already done. We have the 2 holes done. Now what we're going to do is we're going to cut our plate out. Okay, and we begin cutting our plate out with this 1/8 inch polycarb, and we just run through here. Now notice it takes a lot longer to cut it out because we're doing many more passes on it. Okay, so that's basically what we have, and it'd be interesting to see how this is going to work. So that's the end of this presentation, and I just wanted to give you a couple of notes. One is that it'd be really cool if this worked like a 3D printer, which was my original goal, where basically you just push the buttons and everything works fine. Well, it isn't, okay, and I can't figure out a way to make it work like that. So we have to think as we go through here to make sure that what we're doing makes sense, and we'll learn more about that as we develop more complicated parts, and also learn how to more about the details of how these tools work. Okay, with that, I think we're done. This begins our rough cut of the slot, and we're loading T2, which is a 1/4 inch end mill, and it'll be coming down, and then we'll watch it start to cut the slot. That's a feature that we have in the plate, one of the features. And so we're coming in. Our first pass is at 50 thousandths depth, so we're cutting it very slowly. But while we see it cut, and by the way, we'll speed it up in a moment, so don't worry about the slowness of it, is that I'd like to point out a couple of things. The first thing is we're cutting a piece of 1/4 inch polycarbonate. That's the thing on top. I left the film on it, the protective film, the scratch protection film, which was probably a mistake. You see it just kind of all chewing up, but it actually doesn't affect the result that we have. But next time I would do this, I'd take the film off. The other thing is that polycarbonate sheet is sitting on top of a 1/4 inch polyethylene sheet, and that is the sacrificial sheet, which says that as we finish cutting through the polycarbonate sheet, the top sheet, we will make a scratch on the polyethylene sheet underneath, rather than making a scratch on that nice black plate that we have on the mill. Those two pieces, as before, are held together by double-sided tape, and to keep them aligned. We have the sandwich then of the double-sided tape in the high-density polyethylene and the polycarbonate plates. We have those all clamped down using 4 strap clamps in the 4 corners, and you see those strap clamps back in the back 2 strap clamps. We don't see the front 2 clamps. We're also, because the polyethylene has a tendency to bow up when we're doing milling, I also included some right above the 5 in the ×5 speed. There is a stud, which is just a threaded shaft with a bolt on it, and the bolt has a flange. And so the bolt I just tighten that down, and that will push it down into the bottom. Right there, going back to the milling, we have finished the rough cut, and now we're going into the contour on this thing. Now, you said, but we didn't change bits. You didn't have to change bits or the mill ends, because we'll be using T2 for both the rough mill and the contour in this particular slot. Going back to the bolts, the hold downs. Well, let me catch up with this, and we'll talk about the hold downs. The program stopped, and then it's waiting for a tool change. And the tool change, we're going to go to tool TO3, okay, which is the 3/8 inch end mill. And so I'll be showing it to you in a moment. There it is. Put it up in the spindle using what we've done before, and then I will simply restart the program. And then in this case, it should start by drilling, by opening up those 2 1/2 inch holes. So we see it coming into the contact, and we're starting to cut. That again is a 50 thousandths deep cut. And we don't have to keep it that shallow. You could go down to 100 thousandths if you wish. It just, if we keep it shallow, it puts less force on the part and less force on the blade. And it's just easier. It's simpler and safer to handle it. So we cut one of them. Notice we're at high speed. So we got those two cut. There we go. Another halt on the machine, and it's going to ask for tool number 2 again, which is that 1/4 end mill, and we'll use the 1/4 end mill to do the contour cut to make a nice smooth side on these holes. So I was talking about the those flange bolts previously. It's a terrible way to do it. Okay. Or, by the way, there's that contour mill, and the reason the flange bolts are a terrible way to do it is that they're twisted. Okay. You're putting pressure on one side of the nut and not on the other side. A much better way is to use a strap clamp. Okay. I didn't have enough strap clamps when I made this. So after making this one, I ran out and bought another small strap clamp. And so I wouldn't suggest using a stud and a flange bolt to hold down material. So now we're just doing the contour cuts. And we'll do the other side. So now that those will be 1/2 inch holes when that contour finishes, because we're cutting just about 100% of an inch off of it. Okay, we stop again because now we're getting ready to cut out the oval plate, and we're using, as before, a 1/8 inch carbide tip, carbide tool, and that's a 1/8 inch. So it's a T. So we go down, and now we're going to just go through it. Now you notice I'm using the lubricant on this, and you really need not use lubricant on polycarbonate. But you know something? It kind of makes it smoother, and also, to be honest with you, it's easier to get the two plates apart because the lubricant will go down into that double-sided tape and kind of make it a little bit gooey. So notice I cut back that little knob I just turned. I'm cutting back on the amount of lubricant I'm putting out, and so basically now I'm just blowing air. And the reason for cutting back is it was becoming really swamped with just a lot of lubricant on it. And you'll find, I think a little bit later on, I'm going to open it up again. So watch my thumb, and then we'll get a little bit more lubricant, because that was going dry. There we go. We opened it up. So we're just doing a cut, and it's identical. It's the same process as we did in the previous example. And with a little bit of luck, we'll finish this thing up. Again, we could have cut much more quickly on this, but I didn't want, especially with the polycarbonate, if you cut it too aggressively, too fast, what it will do, it will craze. It will make little cracks in the polycarbonate, and that's something we wish to avoid. The carbide mill, these are very sharp, and so they cut polycarbonate very nicely. But could we go faster than we're going? Absolutely. All of these examples, I run at very, very low cut rates. So it takes a long time to cut these parts. If you're making thousands of these parts, you wouldn't cut them this way. But since we're learning to do this, we want to keep the forces low on the parts and also on the tools. So the best way to do it is to cut very conservatively. Takes a long time. This one actually took about 30 minutes to cut. But how many of these will we make? Maybe 1 or 2. So it really doesn't make that much difference. I think we're getting close to the end, and I'm running out of anything to say. Yeah, we went back to normal speed, and I think this will be our final cut. And so now we have a plate with features.